My name is Aloysius Soon, and I'm actually perhaps it might be known from the internet. So I'm not actually Korean, so I'm actually Singaporean, but I've recently gotten the permanent resident visa, so which is great. And I've since been in Yonsei for almost 10 years, and I'm now faculty at the Department of Material Science and Engineering in the College of Engineering. I think that's a very complex question because so I have actually I mean for 25 years of my life I was living in Singapore, and then I decided to do my further degree in other countries, and namely New Zealand, actually Australia and Germany, before coming to Korea. And the reason that brought me back to Asia specifically was that when I was out of the zone, I kind of thought that it would be nice if I could bring back new knowledge, and mentor students within Asia. So at that time, it was not really specifically Korea, but thanks to the introduction of my colleagues when I was in Germany, so she actually recommended, why don't you just try, a couple of years in Korea, and a couple of years became 10 years. So that's why I came in. Of course, I think the culture of Korea is very attractive to me, specifically in terms of the politeness of people, and I think the Korean word is jong. So it's something that's very difficult to describe in English. I don't think there's an equivalent English word. And of course for me, food is very important. So Korean food is just delicious. Strictly speaking, I am the only foreign professor in the department for almost many years since it started. And I think when I first came, they were very curious, and they didn't really know what to do with me. But I think out of professionalism, so they're very professional, they took very good care of me and mentored me. In fact, the very first day, the prior head of the department actually assigned a mentor. Yeah, so and today, until now, he's really a great friend of mine. But after the support and mentoring, they actually provided me sufficient funds to set up my lab, so which is important as well. And overall, I think the culture of the department has been very, very welcoming and very supportive. And I think that's actually one of the main reasons I stayed on as well. I think the answer to this question is going to be fairly dynamic, because it depends when this question was posed, the first 3 years of my time, there were some struggles to break through, because what happened is, so my basic training is actually in science. So my approach to problems, so the motto or the underlying motivation from the group is actually to have a very deep fundamental understanding of the science, so that we can use that science to engineer better, complex, and design better materials. But when we translate this science to engineering, that's where this sometimes this bottleneck occurs, because when the scientist speaks to an engineer, they don't seem to talk the same language all the time. I mean, they do have common fields, but material science is very unique because it's smack bang right in the middle, and that's where sparks fly, good things and bad things happen. So I took time to explain to my colleagues what kind of an angle or approach of research I was coming from, and that took a bit of time. But then that was for the collaborators within the department, and it was also for the students, because the students had never encountered my field. So my field was actually using computers to understand and design. So I guess these days, artificial intelligence, big data is very common. So that's exactly what we do on a daily basis in my group. So that was also pretty intense, but I'm just glad everything worked out well. For us, we actually rely on something that's so fundamental that relies on quantum mechanical theories, actually. So based on these quantum mechanical theories, we actually describe the very unique properties of materials that sometimes it's really difficult to probe from experiments. And from there, we actually extract out the usefulness of these properties. And not only can we understand them better, we can do predictions. Because the predictability of a theory is the underlying goal is its understanding. So if we understand the material more, we can actually afford to design much better materials. So that's kind of the underlying message of this, and these can be very easily done from computers. The flip side is, it's just on the computer. It's never in reality. So my group, especially in recent years, we collaborate extensively with experimentalists, not only in Yonsei but in other esteemed universities in Korea and out of Korea as well. So recently we were fortunate to actually got our work, 2 years work accepted in Nature Materials, which is actually a very prestigious and well-esteemed journal in our field. And it actually it seems very simple, but then the impact is actually quite great. So many times we imagine like your mobile phone, and people are talking about foldable, bendable electronics. And what happens is we were able to identify, we call them liquid metals, and using these liquid metals we can afford to make very flexible, stretchable materials. And from theory, my contribution was to actually understand the mechanism why they worked well, actually. So I think this is something that's very satisfying throughout the career. Historically, that was not our logo, so we had a different logo, more like a more scientifically nerdy logo. But then recently, I thought, because I've seen some of my friends in other countries and their labs have different mascots. So I thought, what sort of a good animal or something that can represent be a mascot for the group. Then came this acronym. So BEAR is BEAR, and I was I think it was 2 years ago, one of the Royal Society of Chemistry visitor came and she asked as well, why is it a BEAR? I said the cheesiest answer is BEAR is an acronym for Be Excited About Research. Okay, yeah, right. So that's cheesy, but so that's where the BEAR comes from.
Be excited about research.
I hope my students get it, but yeah, I hope so. Now, I would say that, of course, it comes and goes. So different generations of students have different abilities to speak English, but generally, throughout my 10 years career, I say Koreans speak English fairly well. I mean, we don't have to speak some Queen's levels English or whatsoever. I mean, simple communication is very important, and it's the same for writing papers. You don't have to write a novel. You have to present your ideas clearly, cleanly, and that's fine. So most of my students are able to do that. And speaking has always been a challenge, and it's been a mixed bag of means, because some students do speak very well. Some students, it's a bit of a challenge for them. But I would say majority of students do fairly well. Reading is kind of okay for them, quite good. Writing, it depends. I just got to know, I think about a year or two ago, that in the education of the Korean system, you don't really write many essays. So I was also a little bit surprised by that, but I guess this is the system. So in terms of paper writing, they don't do so well most of the time, but they get better with time. I think that's good in the sense that they are like a blank canvas. So you begin to tell them and begin to try to help them to shape their interests. Yonsei's College of Engineering is very unique because it's very, very progressive. So like for instance, just only recently, we opened, I think if I'm correct, 3 brand new schools within the College of Engineering. So you've got the School of AI, you've got the School of Semiconductor Systems, and you've also got the School of Vehicle Conversions Engineering, I believe. So you can see that these are things that you can hardly find in other universities. And to my knowledge, or to my impression, these are very good things, because if you allow knowledge to stagnate, you can't progress. So I think Yonsei's College of Engineering is very bold, very progressive, and in terms of academic indicators, we are very good, because I can see people publishing in very good journals, and they have world-renowned reputation. So sometimes whenever I go to certain say conferences Some of my colleagues are also invited as invited speakers, keynote speakers. I think that's actually very, very promising. So that has been the motto for many years, and every year one or two undergraduate students will express their interest in my group, and then normally I will build an internship program. And then through this internship program, like right now we have 4 interns in my group, and we teach them how to operate simple codes. We also teach them how to learn from a graduate school student, or we may bring them to be part of this group, and they contribute with their reasonable skills to part of that project. And then most of them actually enjoy it, and I would say the retention rate is maybe up to 80%. So they actually continue to either do a master's degree or a PhD. So I expect the student to have we call, of course, passion. We call this the top model, so talent, opportunity, and some kind of passion. So this model helps to keep in check the student that gives to bring them to the group to do a suitable project. So the specific passion of the person is very important, because that's what keeps them going. And out of this passion, a very important word that I say, and I find that usually it's found in Korean students, is grit, the ability to endure. Research is it's fun, but it's sometimes not easy. So it's just like that. So the nature of research is you fail, because when you fail, then you learn. Sometimes, of course, you can also learn by not failing, but most of the time, if you look at well-known scientists and engineers, they learn from failing. If the student with a particular passion matches the overall arching theme of my research program in my group, then that's a good match. You have to make them aware, become aware of what they do. But just, keep an active connection with Yonsei, even if you've graduated.
지금 여기 랩실에서는 물질을 컴퓨터를 이용해서 연구하는 작업을 하고 있고요. 지금 제가 하는 작업은 이제 계산을 자동화하는 작업이고, 이제 다른 분들은 또 이제 각자 연구를 하고 있습니다.
저는 이 연구실에 어떤 시뮬레이션으로서 어떤 물질의 물성을 예측하는 거에 대해서 굉장히 매력을 많이 느껴서 이 연구실에 들어오게 됐고요. 이제 이 연구실에서 이제 저희 교수님과 같이 연구를 진행을 하면서 굉장히 활발한 디스커션과 약간 연구실이라는 개념보다 같이 연구한다는 그룹 같은 문화에서 굉장히 좀 많은 친숙한 문화를 많이 느꼈습니다.
기억에 남는 순간은 여러 개가 있죠. 좀 여러 뷰로 볼 수 있을 것 같아요. 개인의 성장도 있었고, 또 이런 소속 그룹 원으로서의 그런 그룹에서 뭔가 그룹이 성장해 나가는 그런 느낌, 성취도 있었고, 또 교수님과 저와의 관계 속에서 얻는 즐거움도 있었고. 일단 두 가지 이렇게 나눠서 생각할 수 있을 것 같아요. 분야, 필드에 대한 얘기가 하나고, 그 다음에 이게 교수님에 대한 얘기니까. 교수님이 어떤 사람인가, 이 두 가지로 얘기를 할 수 있을 것 같은데, 일단은 제 생각엔 교수님이 학생들한테 주는 가장 메리트라고 해야 되나? 이런 게 성장할 수 있는 기회를 주는 거죠. 그러니까 예를 들면 시작하는 학생에 맞는 테스트를 주고, 이제 또 내가 어떤 뭔가 박사 학위나 뭐 학위 과정의 중간에 있을 때 또 뭔가 좀 챌린지 해볼 만한 것들이 있을 수 있거든요. 예를 들면 외부랑 콜라보레이션을 같이 한다던가, 그것도 국내가 아니라 해외에 있는 연구자들하고, 아니면 뭐 학회를 간다던가, 뭐 이렇게 좀 챌린지할 만한 포인트들을 이렇게 줘서 이렇게 뭔가 중간중간 레벨업 할 수 있는 그런 포인트를 많이 주시는 것 같아요.
NCC 화이팅!